Welcome to Vision Plus and welcome back to this unit for mathematics and complex numbers. We are now on example 3 under the Argand diagram. Example 3 has given us three complex numbers and the question says that we need to represent the following on the Argand diagram. And part A says that we need to represent the complex number Z1 on an Argand diagram. What is Z1? The complex number Z1 was given as negative 5 minus 4i. What do you need to do? You need to draw your axis, that is the vertical axis and the horizontal axis. The horizontal axis is what we are calling the real axis. This is where we represent the real parts of the complex number. And the vertical axis is what we are calling the imaginary axis, where we represent the imaginary part of the complex number. This is just the complex plane. Now we need to represent our complex number. If you look at these numbers, we have 5 and 4. So it means now the biggest is 5. So we need to label our axis until we have included 5. So let me say here, I have here 1, 2, 3, 4, 5, maybe 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Because we need to accommodate the maximum number, which is 5. So this is 1, I'll call this 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Remember, the left sides, we have 0 at the origin here. This left side contains negative numbers. The downside contains also the negative numbers. Make sure your work is organized and presentable. Now, after putting these numbers, then you come and check. You can start by locating on the imaginary axis or on the horizontal axis, which is the real axis. So if you come here, you are saying negative 5, which is a real part of the complex number. So it will lie on the real axis. So on this real axis, which is the horizontal line, let us look for negative 5. Remember, negative 4, negative 5, and negative 6. So this is negative 5. I didn't want to congest my work a lot. So this is negative 5. And then on the vertical axis, let us look for negative 4. This is the imaginary part, negative 4. So negative 4 will be down here, which is here, negative 4 on the imaginary axis. Now let us look for where negative 5 here will intersect with this negative 4. It is somewhere here. We have said that our Argand diagram is not accurate. It's just an approximation. After drawing a straight line from the origin up to the point of intersection, we put the arrow on top here. And this is the complex number, which is Z1. Just mark it here as Z1. Or sometimes you can just write this on it. Negative 5 minus 4i. But simply put Z1, which is the same as that. So going to part B. Part B says that we need to represent Z2. What is Z2? Z2 is 6i. I'm going to be faster here. We have done enough numbers and you are now more familiar with what we are doing. So 6i minus 3. So you come and then you draw. Come here and draw your axis, the vertical axis and the horizontal axis. This vertical axis is what we are calling the imaginary axis. The imaginary axis. This is the real axis. Then if you look at your numbers, you have 6 and 3. So the biggest is 6. So you come and mark to 6. You can just say this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. Remember, don't forget these are negative values. If you don't indicate that they are negative, the whole graph is 0. You will fail. This is not mandatory, but putting it there makes it better. Now, after drawing the axis, this is just the complex plane. Now we need to indicate. Now here we are seeing 6i is positive 6i. It is I. Since it is I, it must lie on the vertical axis. So let us look for 6 on the vertical axis. Positive 6, it is here. And then we need to look for negative 3 on the real axis, which is the horizontal line. Now, negative 3 is here. This is negative 2 and negative 4. In between is that negative 3. Then you look for where they're going to meet. So just from negative 3 here, you move up vertically, approximately vertical. And then here we have negative 6. So this is where they're meeting. So what do? We draw a straight line from the origin to that point at intersection of the real and the imaginary values, which is there. After drawing that straight line, we put an arrow on the head, and this is complex number Z2. Since now there's no space here, you just point at it and say that is my Z2. So that is the Argand diagram of the complex number Z2 of part B. Now going to part C. Part C has given us Z3, which is negative 4 minus 2i. Go straight and draw your. Remember, this axis must be straight, vertically straight and horizontally straight. So I'm drawing with freehand to save time and to save your MBs, your bundles. And then here we have the imaginary axis. Now, to make your work easier, look at these two numbers. What is the biggest number? 4. Mark the axis 4. That means I will mark 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 4. Do not forget that the left side of the real axis is negative and the down side of the imaginary axis is negative. This is the complex plane. Now you come, we have negative 4, which is the real part. Negative 4 is a real number. It's a real part of this complex number. So you come to the horizontal axis, which is the real axis, look for negative 4, which is here. And then for imaginary part, we also have negative 2. So you come down on the vertical axis, look for negative 2, which is here. Then you look for where they're going to meet. This is where they are meeting. After getting where they are meeting, then you pass a straight line joining the origin to that point. Like that. And then you put an arrow on top. Then you say, this is my Z3. And that is the solution. You students are very funny. You will find somebody would locate negative 4 very well. Also comes to locate negative 2 very well. And then they end up joining from here up to there. That is wrong. You do not join from the real to the negative, from the real to the imaginary part. No. But you look for where they are going to intersect. On a graph paper, there are vertical lines and horizontal lines. And here, we use that same concept. So you don't join negative 4 to negative 2, but you find the coordinate. You find where the point is located. Okay, you find where that point is located in this format. So this is the solution to example 3.